Welcome back. This is day 79 of daily LeetCode. We are back once again, right? Day 79. We have a lot of problems to do. Yesterday we were working on 3-sum. We're trying to come with a n cubed solution, but we're running out of time. And I think there's something here where we should be able to figure this out. We had another version of this we did a long time ago that we were able to figure this out with an n cubed solution. That being the case, right, we had some comment. I think we had a legendary comment from, oh wait, Hucky has a subscriber. Hey, simple as that. 292. Let's go. Let's go. And then we had a legendary comment from Thomas Wong himself. And this is just too true. Right? And I think my camera is so big, you might not actually be able to see it. Right? Legendary comment. 3-sum is the kind of question. Actually, can't see it. 3-sum is the kind of question. Every time you do it, you have a chance of messing up. And that's just so true. I'm not exactly certain why that is. But something about this question is the memory, when I think of it in my head, the memory fragment, the way the memory fragment comes together is just messy for some reason. It's just messy. Every time I think about it, like just the way you solve the problem, it just seems so unintuitive. I'm wondering if it's because we just haven't done enough string and array problems to have it like the memory be stable. But something about it is just all over the place. That being said, I'm noticing that playing catch up on all these problems is taking a long time. So we might have to speed it up and start speed running these problems. So most of the times we already know the solution. Maybe it's not important, and you guys can let me know in the comments below. Is it important, right, that and my camera's still too big. Is it important that we do that every time we do a problem? Like I try to do the Feynman method to explain the problem while I'm doing it, to learn from it. But in a lot of these problems, we've already done it. We're just kind of doing it, right, just to maintain the memory of the solution structure, right? Because to some degree, we already know how to solve it. So just maintaining the solution structure in memory, just so that when we have similar problems, or we can kind of abstract or make these concepts portable, right? So that's really what I'm thinking about when we do this. So I'm wondering if maybe we should just start speedrunning, but then speedrunning actually gets a little bit messy. So I don't know. I really don't know. Something I'm really thinking about here. The thing is, this is just a sucky part we just have to deal with. Once we actually get back to new problems regularly, which I think should be in like 2 weeks, then we should be good. But it remains to be seen. You know, we'd like to continue making progress on it, but it just remains to be seen. And there's not going to be all problems in space repetition, just the grind 75, just trying to get the most important ones in. So maybe what we could do is filter out problems that aren't part of the grind 75. Right, and just keep going. But that being the case, right, I'm pretty sure 3-sum is part of the grind 75, so that's what we're going to do. Intersection of 2 linked lists isn't, and so I think these bottom 3 are. So that's what we're going to do today. And yeah, we're just going to jump into it today. It's about 12 p.m. EST, so at the time this timer ends, it's going to be about 12:30 a.m. The grind does not stop, especially for the members within the Hyperbolic Coding Coalition. So you're going to want to join to make certain, right, that you're in the Discord getting those secret cheat codes as needed. So make sure to join the Discord, right, because you're going to want to do that. And then we're just going to jump into it. Thank you for being patient with these problems. We're going to start getting to new problems soon, right? Because I think when I look at these videos back, it looks just like I just do old problems. But you know what they say? I mean, we've already learned so much just doing all these old problems, which is really interesting, especially while reading the ADM. So a necessary evil. But let us continue. We're back once again with day 79, right? Daily LeetCode. So we're just going to jump into it, right? Actually, I'm not certain if we're going to, yeah, we'll just finish 3-sum. So we're just going to do it. We're going to drop the n cube solution. And I think we just need to focus hard, because we're going to do 30 minutes. So we just need to go hard in the 30 minutes, right? Just to get these other problems in. So that's what we're going to do. And we're just going to jump into it. So 30 minutes, let's do it. So you're working on 3-sum and doing an n cubed solution. I was thinking that we probably could have come up with a better way to do this, but that does not seem to be the case. So we're just literally just going to restart, right? And we know that, right, given an array of numbers, right, we have an algorithm that can get us, right, given an array of numbers which is sorted, we know we have an algorithm that can get us these values, right? Or we know that, right, if we have 2-sum, right, we know if we have a 2-sum algorithm that can find, right, given an array of numbers, 2 numbers that sum to a target. Since we're looking for 3-sum, all you have to do is give it a seed number, right, and just do 0 minus the seed number, right? So 0 minus 1, right, would give us 0 plus 1, which equals 1, which means that we're just looking for 2 numbers that sum to 1. We'll have these 2 here, right? And then later on, right, we can just kind of have it work through this array slowly, right? So we know that given a seed number like -1, we can use the rest of the array, right, as our range to search for using this 2-sum algorithm. The requirement for it is that the input be sorted. So if that is the case, right, we can aim for a conceivable runtime of n squared, since the 2-sum algorithm, right, would run in 2-sum would run in linear time. So if that's the case, if we're going to do this for every array element, I might be asking, why would we do this for every array element? It's because we want to have all pairs that sum up to 0, right? So we have to do this for each element, right? And when our range is going to be shrinking, right, each time, because our input is going to be sorted, right? And this way, right, we can actually have our input, we can iterate through the array, and for each number we'll use it as a source number, and then check if this range, right, has any if this range, right, excluding the number, right, has our goal complement number. So our complement number is going to be 0 minus -4, which is going to give us, or 0 minus -4 is going to give us +4. So we're going to look for this, in this range, any 2 numbers that sum up to 4, none, right? So we can actually start implementing this, so we can make sure, right, what we're going to want to do is iterate over nums, right? For each number, right, we're going to call this 2-sum algorithm, right? Call 2-sum, right, for each num. Once we call 2-sum, right, we'll have, you know, maybe a triplets array, right? We'll say add 2 triplets if non-empty, right? If the output, right, of 2-sum is non-empty, we can add 2 triplets, right? And the other thing we're going to want to make sure, right, we want to avoid duplicate triplets, right, of numbers. And to do that, all we have to do is skip numbers that are right next to each other, right? Because we have -1, we know that we can get 0, right, by looking for anything that sums to 1. Anything that sums to 1. So we can find that right here with 0 and 1, but if we look ahead to the next -1, we can also find that with 0 and 1. So we can remove duplicates by skipping these nearby numbers. Right. So to do that, all you have to do, right, is make sure that when we do 2-sum, right, we have to make sure that let's just say num sub I, right, does not equal num sub I minus 1. We have to be careful because in Ruby, right, the array wraps around. So at 0, we're going to get -1, which is definitely something we don't want to deal with. And then we're going to have to duplicate that functionality within our toSum function as well. So let's just start implementing this. We want to iterate over nums. We want access to the indices. So we're going to say nums.length.each do, and we're going to have access to I. Right, and we want to say if num sub I does not equal num sub I minus 1, the problem being, right, that we don't want to skip when we start at 0, right? If we do I minus 1, we're going to get -1, which means we're going to wrap around to the end of the array, which is troublesome. So maybe we'll have a special case. We'll say if num sub I does not equal num sub I minus 1, or I equals 0, right? Just to get our start case as well, right? And we'll say output is equal to toSum, right? And then we'll say output.push toSum if triplets, which is our output that we're returning, right? Because we want the group of triplets that sum to 0, so return triplets. We'll do triplets.push output if output.length does not equal 0, right? And then we're gonna have this toSum function, right? So what are we gonna call it, right? We want to give it our seed index, right? Which is gonna be the index we're currently at, and access to the nums array. So we should be good there. Then we can do def toSum, right? We're gonna have we can just call it index, right? And nums, and we're gonna have end, right? And like we said earlier, the one thing we have to make certain is that our nums is sorted, right? Or our toSum algorithm can't work. And so the range that we want to work on, right? If we give our source index, which is -4, the range that we're going to work on is actually past -4. So we're going to say left is equal to index plus 1, right? And right would actually be equal to nums.length minus 1, right? And so this toSum algorithm works. We're just going to say, hey, while we're not close to the number we want to be at, if we're greater than it, right? Since our array is sorted, if we're greater than it, the best way we can get close to reducing that value is by subtracting this greatest number on the right. And if we're smaller than it, the best we can do, right, to get closer to it, right, is actually to go to the next number, right, -1. And if we add those two, maybe we'll get 0. And we should be able to get closer using that idea. So we'll say while left is less than right, right? We're going to say our sum is going to be equal to nums sub index, right, plus nums sub left plus nums sub right, right? And if sum equals 0, right, then we're going to have to output this array, right, which is going to give us our group of triplets that we're interested in. So we can say output is equal to an empty array, and we'll just return output, right? And if this sum equals 0, right, then we found a group of triplets that sum to 0. So we're going to want to do output.push, right, nums sub index, nums sub left, and nums sub right. But then we have some other things to handle, right? Because we're going to want to skip the next index, right? Because we have -1 here, right? We know that -1 is our source index, right? And then let's just say we have -1 plus 0 and 1. right? We don't want to keep working at this -1. We want to skip to the next index, right, and have it keep searching for all possible numbers that sum up to 0, right, for this source index. And so to do that, we can increment left by 1, or just to make sure we make progress. And then here, we're going to want to make sure, right, that nums sub left, right, if nums sub left equals nums sub left minus 1, then we're going to want to do left plus equal 1. So we want to skip all duplicate values, right? So if our left was equal to, let's just say -1, right? We'd add 1 to it, which means we're good. But let's just say there are multiple duplicates in a row, then this while loop would skip all of those values, right? But in the case where else if sum is greater than 0, right, the way we fix that is actually by, if our sum is greater than 0, the way we can get closer to 0 is by subtracting our large value. So we'll say right minus equal 1. And then we can do else if sum less than 0. The way we can get closer is with left plus equal 1. Right, and we'll see if this makes sense. So we definitely want to go back to the example test case. So our output is -1, -1. So it's saying we had the wrong answer, but the output is exactly the same. -1, -1, 2, -1, 0, 1, empty array, and then all zeros. Maybe there's just too much in here. Oh, we have I see what's happening. We have an array of arrays, so a 3-dimensional matrix. We push an array onto this. Right, what we return is an array of arrays. So I actually don't know how you would concatenate. Let me just check real quick. So apparently you can just call concat. So that's what we'll try. Triplets equals triplets dot concat output. So this does seem to work, and then we end up with n² time, since 2sum takes linear time, and we end up running it. Actually, it takes n², but then I think it actually ends up taking, yeah, n² time, because I think n log n is actually better than n². Let me check. Okay, so we're definitely wrong, right? N² is, oh no, x². Well, nx, maybe it's the same. X² is worse than n log n. So we're going to say that this is actually going to be dominated by n² time complexity. Right, so then now it's 3sum. We have number of 1 bits. We're just going to speed run all these problems. Don't know how to do bit shifting in Ruby. We're going to try it anyway. Write a function that takes an unsigned integer and returns the number of 1 bits it has. So we should be able to just do 32 operations over n. We can do 32 times, right? And we'll say ham equals 0, return ham. And then we'll say is ham plus equal n and 1, right? And then we'll bit shift n down 1. Okay, so this should be constant time since we can do it in 32 operations. longest string without repeating characters. Definitely sliding window. So you have ABC, ABC. The answer is ABC. We want the longest substring without repeating characters. So I think we could just do a linear iteration over it and then do sliding window, do A, B, C, A, and then as soon as we get stuck on a value, right, or an index, right, where the occurrences are greater, right, a right index where the occurrences are greater, we're gonna use our left index, right, and then keep moving forward, decrementing occurrences, right, until A is, or that right, the character starting that right indice in the hash map is below 1. And then at each iteration, we can take the max. So I think what we could do is, we'll say, right, 0, right, going to s.length.each do I, right? And we're going to have a character, which is going to be equal to s sub I. We're also going to have a hash, right, with the default value being 0, right? We're going to say, right, whenever we have a character, we're going to say, hey, add this character to the hash map, right, and then increment its occurrences. Right, and on the outside we can have a left, right, which is going, our left side of the window, which is going to be set to 0 to start, right, and we're going to say, hey, if, right, the occurrences for if the occurrences for the character, right, is greater than 1, because I here is technically right, and we can change it to be right, maybe that's easier to read, right, hash sub car, right, is greater than 1, then we're going to do, right, we're going to have a while loop, right, and we're going to say, right, starting from left, right, and then going up till right, each do idx, right, now we're going to remove values from the hash, right, until hash sub car is less than 1. So in a sense, we could remove this if, right, since it's going to be a while loop, and we could just fuse these together into a while loop, right? Could say while left is less than right and hash sub car is greater than 1, right? Then we're going to want to say hash sub s sub left minus equal 1, and we do left plus equal 1. Right, so we'll clean up values in the hash, right? And then presumably once we get out of here, right, we have a window that shows us, right, our string where the string has all unique characters, right? And that's what we want. We want that length. So we can say length equal to infinity, set it equal to negative infinity, right, that way. Can our string be empty? Our string can be empty. In that case, right, we'll say return 0 if s.length equals 0. I set length equal to, I actually don't know how you do max, but maybe there's something called, let me check. So it looks like we can just use the one on the array. All right, we'll set length equal to the max, right, of length, or right minus right, because let's check, right? So we have A, our hash would have 1 in it, B, our hash would have 1, C, our hash would have 1, right? A, our hash would have 1, right? Once we do that, left would be less than right, and hash sub car, which is the right-hand side, would be 2, right? Then we'll say hash sub S sub left, which would be 0 minus equal 1, right? And left plus equal 1, which means our string is now 1 and 0, 1, 2, 3. 3 minus 1 gives us 2, but our length is actually 1. Say right minus left plus 1 dot max, then we could return we could just return length. Something seems too simple about this. 0 going to S dot length, do right, get the character, we put it in the hash, ABC, right? And our longest character at this point is length left plus 1, uninitialized constant, float infinity. I think you can just do 1.0 divided by 0 and do negative. I wonder if Ruby is just slow or if this is just slow. So I actually don't understand why this one is 300 milliseconds. That's a little crazy. This should run in linear time though. Left is less than right. So you have to check the whole string. I wonder if this max function is just slow, but I truly don't understand why this is so slow. This should be linear time though, and since S consists of English letters, digit symbols, and spaces, it means that our hash would have a constant size of maybe 72. English letters, uppercase and lowercase, would be 52, plus 10 digits would be 62, plus symbols and spaces probably give us like 72 or 74 different characters. So linear time, constant space. "5 minutes, intersection of two linked lists. Given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. Two linked lists have no intersection at all, return null. And if the following two linked lists begin to intersect at node C1. Test cases are generated such that there are no cycles anywhere in the entire linked structure. Note that the linked list must retain the original structure. The nodes intersect at node A and they'd like us to return null." So this one, I think the cheat code to this one, right, is realizing that if we can create the same runway until the intersecting node, then we would actually we could do a sequential check, right? So imagine if B1, can you guys see B1? You can't really see B1. Imagine if B1, right, didn't exist and they had two nodes both respectively until they would merge into C1, then you could just do a sequential check for identity, and if the nodes are ever the same, then you can return that node. And so that's pretty much the intuition behind this problem. And the way to do that is just to get the length of the linked list, right, which would be 1, 2, 3, 4, 5, 6 for B, and the length of the linked list for A, which would be 5. And if we do 6 minus 5, the absolute value will give us 1, which means we want to shift the longest linked list up by 1. And then we can do a sequential check for identity. Now, I don't know if there's any cycles. I don't know if there's any cycles. Oh, generator says there are no cycles. Okay, because this would not work if there are cycles. So figure out longest list, right? Shift longest list up, difference of lengths, sequential check for identity. All right, so we need to figure out the longest list. So to do that, we need to figure out head A. We can call it A length, which will be equal to 0, and we'll call it B length. We'll say temp is equal to head A, right? And we'll say while head A does not equal nil, or we can just say while, not head A, but while temp, we're just going to say that A length plus equal 1, right? And then we'll do end, and then we'll do temp equals temp dot next. And we want to duplicate this, right? So we can figure out the longest list for B, and we can't do this, right, without knowing the length of both lists, right? So here we'll set temp now equal to head B, and then we'll change, now we'll increment B length, and we'll say temp equals temp dot next. So after that, we should be able to put A length, right, and puts B length, and let's see if that works really fast, right? We know, yeah, we have 2 linked lists, right? One of length 5 and one of length 6. Right, so now we have this information. Now we just need to know which one's the longest. We'll say, okay, if A length is less than B length, right, then longest, right, must be head B. Otherwise, it must be head A. We can duplicate this and say, okay, if longest, right, is equal to head A, then shortest must be head B. Otherwise, it must be head A. Right? Now you want to shift the longest list up the difference of the lengths, right? So we'll just say, right, 0 going to longest minus shortest dot abs, right? Or we can also just do longest minus shortest dot abs dot times, right? And we want to actually shift longest, right, up to longest equals longest dot next. So I wonder if we can do times like that. Oh, not longest, I'm going to do A length minus B length, undefined val for 1. Undefined method val for. Let me check if you can do abs in. So you can do times. I mean, you can do abs. There's no times here. I'm not sure why this is giving me. I just want to do A length minus B length dot abs dot times. So 1 times. Undefined method val. So we'll just switch it up, right? We'll just do shift equals A length minus B length dot abs, and then we'll just do 0 going up to shift, right, dot each. And we'll do longest equals longest dot next. So I think what they're saying is I have to define a value. Yeah, I don't get it. I don't get it. If I do puts shift, what's the problem here? It's 1, and for some reason I can't do. Do I need a do? So what if we did, that's what we're doing, 1 to 5 dot each do. I tried to do it without. All right, I guess I just don't really understand. We're just gonna do it like this, longest equals longest dot next. We'll do end. I don't get it. 0. I'm going from 0 to 0 dot each do. Yeah, I don't quite understand why this isn't working. I'm just gonna copy this line and you put them side by side. I don't really get what the problem is here. They have 1 to 5. I have 1 going to shift each C, right? I place this with longest equals longest dot next. Or maybe they're literally saying that I'm not returning anything. Oh man, so what I was doing was fine. They're just saying that I didn't have a method. Yeah, they're just saying I didn't return anything, which is a little bit silly, but we're just gonna say while longest does not equal null and shortest does not equal nil, right? We're just going to say if longest equals shortest, return longest. Otherwise, we're just going to do longest equals longest dot next. And shortest equals shortest dot next, right? And if they would never find, if they never intersect here, then we know that we can just return nil because they have no intersection. And we're missing I say return longest if longest equals shortest. Right, so this one is a little slow, but I think it just might be Ruby. It might be also because we're doing all this printing. But this should be m plus n time with constant space. So that's going to be a wrap. So I think we might try the speedrun approach just to get through more problems, but that's a wrap on day 79.